Do you know how to use the Pythagoras theorem to solve questions in mathematics? Do you also know when the Pythagoras theorem is used to solve questions? Welcome, lovely one, to Maths Made Easy tutorial video with me, Osei Mensah, popularly referred to as Sir Tony, the mathematics doctor. In this video, I am going to teach you how and when the Pythagoras theorem, also referred to as the Pythagoras formula, is used to solve mathematics questions. Before I teach you how to apply or use the Pythagoras theorem, I would have to introduce you to the secret of applying the theorem or the formula, which are the right angle triangles. These diagrams represent right angle triangles. Now, a right angle triangle is any type of triangle which has any of its interior angle as 90 degrees. The 90 degrees is referred to as in mathematics as right angle. So a right angle is a 90 degrees angle. So if a triangle has 90 degrees within it, it becomes a right angle triangle, also referred to as the right triangle. So look at this diagram. The triangle ABC is a right angle triangle because there is a 90 degrees angle within the triangle. And this is a right angle. So it has made this entire triangle a right angle triangle. 1, 2, 3 angles are there with one of it as 90 degrees, and that is why it is a right angle triangle. The same thing to this diagram, which is a triangle PQR. It has one of its interior angles as 90 degrees, even though there is an angle theta. That is not our concern. Once there is a 90 degrees angle within the triangle, this triangle is qualified to be a right angled triangle. Don't forget, right angle means 90 degrees. So if there is a 90 degrees, there is a right angle. And if there's a right angle, it becomes a right angle triangle. The same thing applies to triangle MNS, which is also having 30 degrees and 90 degrees. But because of the 90 degrees angle inside the triangle, there is a right angle inside the triangle. That makes the entire triangle a right angle triangle. So these are right angle triangles. Now this is the Pythagoras theorem itself. This is how we quote it. And please watch it well. It quotes hypotenuse squared is equal to the opposite squared plus adjacent squared. That means that before you can quote this formula, you must know your hypotenuse. That will be the subject with the squared. And then it is equal to the opposite squared plus the adjacent squared. That is why I said anybody who doesn't know the sides of the right angle triangle cannot quote the Pythagoras theorem. Now, with the help of this triangle, I'm going to use the sides to substitute into this formula for you to know how it is done. Then I'll solve a question with you. Let's go. Hypotenuse from this diagram becomes where the 90 degrees is pointing to. So AC is my hypotenuse. Apparently, it is the longest side. So the line AC squared now equal to the opposite could be any of these two sides since there is no angle under consideration. So let me use this AB as my opposite. So the side AB with a square. Now plus, that is a plus. The adjacent is the last side BC. So BC squared. This is how we quote the formula accurately. So the formula must be in your mind. Now let us solve a question for you to understand with the same formula. Now let us take a question to help you use the formula well. Now in this diagram, it says find the side or the line AC. And this is the line AC. Now please watch the line AC well. You realize that it is a hypotenuse. Since the 90 degrees points to this side, and that is the longest side also. So the hypotenuse is the longest side, and it is the side where the 90 degrees points. So we want to make hypotenuse the subject. Now watch here. We are using the Pythagoras theorem because of two reasons. Number one, because the Pythagoras theorem is only used on a right angle triangle. That is a triangle with a right angle, which is a 90 degrees inside it. Two, they will give you two sides of the right angle triangle, and then the question will ask you to find one side. And that is clearly what is happening here. I've been given 4 as my opposite, and the adjacent is 3. And I've been asked to find the hypotenuse. So two sides given, find one side. Let us apply the Pythagoras theorem. Now with the theorem or the formula already written, let us see. Now the hypotenuse squared. So the Pythagoras theorem states hypotenuse squared, and my hypotenuse is the AC. So AC squared is equal to the opposite squared is AB. I've been given as 4. So 4 squared plus, and then the adjacent squared is BC, which is given as 3. So 3 squared. Now let us solve it mathematically. Now still AC squared is equal to 4 squared is 16 by calculator, plus 3 squared is 9. Now let's add, since they are real numbers, they are constant. So let's add 16 plus 9 is giving us 25. So AC squared is equal to 25. We have to make AC the subject, but not AC squared. And please, this time around, take your time. Anytime there is a square in the presence of the equal sign, we need to introduce the square root. And we'll take the square root of this side, we'll still take the square root of this side. This is what I mean. Square root of AC squared is equal to the square root of 25. Why are we doing this? So that the square root can cancel the square. That is how mathematics is. It will allow the two to cancel, remaining with the AC. So the line AC will be equal to the square root of 25 is 5, which is in the meters. It is positive 5 because we are talking about line. Lines are positive in value, so we can't say plus or minus. So the answer for AC from this question is 5 meters using the Pythagoras theorem. So please go through this, pause your video and go through it systematically. This is the Pythagoras theorem and its application. Thank you very much. Let us take another question so that you can solidify your understanding with the Pythagoras theorem. Now in this question it reads, find the side PR in the diagram. Now this is PR up here and that is the diagram. This diagram is a right angle triangle because the triangle has a 90 degrees as one of its interior angle. So 90 degrees for right angle. And then the triangle having right angle makes it right angle triangle. We have been given two sides, 5 centimeters and 13 centimeters. We are asked to find one side. So we use the Pythagoras theorem. Don't forget Pythagoras theorem because it is a right angle triangle and because we are asked to find one side given two sides. This is our formula. The hypotenuse squared is equal to opposite squared plus the adjacent squared. This is a Pythagoras formula or theorem. Now, which one is our hypotenuse? 90 degrees point here, and this becomes our longest side. So since the 90 degrees point here, 13 becomes the hypotenuse. So QR is a hypotenuse. So 13 squared is equal to, now the opposite. Now please, to find the opposite in this diagram, you need to take your time. This time around, there has been a given angle. And this given angle is theta, which is also referred to as the angle under consideration. And theta is the symbol for unknown angle. So we don't know the value of the angle here, but we know it's a symbol, theta, or a variable. Now look at this. The side which will be directly facing the given angle will be the opposite. And our given angle here is theta. It is the angle under consideration. So the opposite will be PQ. So our opposite is 5. So we come with this 5 and we square it, plus the adjacent has also not been given because we are looking for the adjacent as PR. So it will be the variable or the side PR and square. Then we'll go ahead and make PR the subject. 13 squared will give us 169. Is equal to 5 squared is 25 plus PR squared because it is not having a value, so we maintain it. Now let's continue. There is a real number here and there's a real number. That means the constants are there. We'll move this constant from the right hand side to go and join this constant at the left hand side. And once there's an equal sign, when 25 moves in a positive nature, it will become a negative at the left hand side. So this is how we write it, 169. This one moves to become minus 25. Now close it up with the equal sign. Then the number remaining, which is the variable PR squared. That is what we are looking for. Now 169 minus 25 will give us 144. It's equal to PR squared. Since we are making PR the subject, we'll have to eliminate the square. And in the presence of an equal sign, the square can be eliminated with the help of the square root sign. So square root this side. Because there is an equal sign, you have to also square root the other side. Whatever you do at this side, do the same thing to this side of an equal sign. Now what does it do? The square root will cancel the square, and that is mathematical. So once it cancels, there will be no square root. But here, it is a constant number, so the square root of 144 will give us 12. It's equal to PR. So we can now conclude that therefore, the length PR is equal to 12 centimeters. The unit is centimeters because that is what is in the diagram. So we've used Pythagoras theorem to solve the length called PR in this diagram. Thank you very much. Lovely one. Thank you for sticking and staying with me to the end of this video. This has been Pythagoras theorem display and how to use it in solving mathematical questions. Please, if you found this video helpful, don't forget to give us a thumbs up by liking the video. Also, please share the video to all your friends who find this video important. Please like our page and follow us on all our social media pages. If you want us to shoot any video for you, please comment in the comment section. Leave a comment for us, the kind of topic that you want us to help you with. And also we have online platforms that will train students on how to understand, love and pass mathematics. Join our online platform. You can just send me a message me, and let's talk about that. Thank you very much. My name has been Anthony Osei, Mensah, popularly referred to as Sir Tony, the mathematics doctor. I'll come your way again with other videos. Thank you very much for your support. We love you and God bless you all. Bye.